Hello, and welcome to this introductory training module for estimating and bidding. This course will provide a basic understanding of the processes involved with calculating an estimate and bidding a project. Project Solutions, Inc., PSI, has been contracted with state DOTs since 2000 to provide business training and one-to-one consulting. We look forward to working with you to build your business using strategies that work. Why do you need a good bid process? It's a commonly known fact that most businesses fail within 3 years of being established, and that the average business owner will fail the first 2 times they start a business. According to the American Association of Cost Engineers, construction firms make up about 8% of all businesses in the United States, yet constitute 17% of all business failures. New businesses fail at an alarming rate, and new construction businesses fail at an even greater rate. Why do construction firms fail so often? There are many reasons, but most of the time it is due to poor estimates. The lifeblood of construction firms is through profits based off bids or negotiations. The quality of a bid is dependent on the quality of the estimate behind the bid. Estimates that are too high leave a company uncompetitive in a bid, and estimates that are too low leave a company unable to make a profit. Before we get started, let's go over the difference between an estimate, a quote, and a bid. Estimate. Contractors use estimates to calculate their expected costs to complete a project. Specifications for a project are analyzed to determine the raw materials and labor required, and the contractor then solicits quotes from suppliers for the raw materials. Overhead charges are also typically included in an estimate. Quote. A quote is a figure that a contractor gets from a supplier for the price of materials they need for a job. Quotes are often good for a certain length of time. Outside the given time frame, the price of materials may change. Quotes expire because the materials involved in a construction project are commodities and their prices fluctuate based on supply and demand. A good example of this is lumber. Suppliers are not able to just create more 2x4s if demand exceeds their expectations. Trees need to be harvested, processed into lumber, and shipped before they can be sold. Another example may be excavation services, where costs may vary depending on the price of diesel at the time the work is performed. Bid. The word bid in construction may refer to a document that offers to perform a specific job at a specific price within a certain period of time. It may also refer to the specific price of the project offered in the document. This training module provides an introduction into the process of estimating a bid. We will also discuss the additional supportive services available at no cost to certified DBEs through PSI. There are about as many different methods of calculating an estimate as there are construction companies. The distinct types of estimates in use today can be categorized into a few basic styles. Order of magnitude estimates. Order of magnitude estimates are essentially ballpark figures. Construction firms most commonly use this type of estimate as a tool in the screening process when evaluating a project's desirability. They are very quick to produce and do not rely on detailed design information. The accuracy of an order of magnitude bid generally depends on the experience of the estimator. Parametric estimates. Parametric estimates are more detailed and therefore more accurate than order of magnitude estimates, but are less detailed and therefore less accurate than detailed estimates. Parametric estimates are based upon the size and scope parameters of a project. They are approximate estimates and are especially useful for highly repetitive types of projects. Often, parametric estimates are used for parts of detailed estimates. Detailed estimates. Detailed estimates, also known as definitive estimates, form the backbone for the bid, the contract negotiations, and the project cost control. Detailed estimates involve quantifying all the elements involved with the scope of work and pricing out each of those elements. Depending upon the size of the project, detailed estimates are highly specialized and take a great deal of time to complete compared to other types of estimates. This estimating module discusses instructions for detailed estimates. Detailed estimates are the estimates in which construction bids and negotiations are based upon. Once the project is underway, the detailed estimate also forms the basis for project cost control. A detailed estimate breaks down a project into each of its component elements, quantifies those elements, and then prices them out. The elements that the estimate is divided into are more or less up to the estimator. The basic rule of thumb is that if it's different, keep it separated. The steps to completing a detailed estimate are: review the contract documents, perform a pre-bid site visit, attend the pre-bid meeting if one is offered, develop a bidding strategy, solicit a prime contractor unless bidding is prime, notify your bonding agency, estimate the general conditions, perform a quantity takeoff from the plan set, determine the units of measure, determine prices for each element, estimate the labor, estimate the equipment, determine overhead, determine the acceptable level of risk, determine the markup for profit, calculate markup for bond, and finalize your estimate. These are the basic steps used by most construction contractors. Of course, every company does their estimating a little differently, and these steps are not necessarily performed in sequential order. We will cover each of these steps so that no matter what your trade, you can successfully estimate a job. Number 1. Review contract documents. When preparing an estimate, the critical contract documents include specifications and drawings and plans. As a bidder, it is the responsibility of the contractor to know and understand what is included in the contract documents. The project manual or spec book provides instructions on how the prescribed work is to be performed, including material and equipment requirements and any restrictions or conditions on that performance, how the quality and acceptability of work will be determined, allowable tolerances and how deviations from these tolerances will be handled, how payment for work will be made, how change conditions are to be handled. Because specification books are often inches thick, many contractors only read the section that affects their trade. It is imperative, however, to review all specification sections before you sign a contract. You are contractually liable for all requirements included in the complete document. The General Conditions section, for example, contains contractual requirements for job site safety, submittals, cleanup, change orders, and how to get paid. Plans and drawings. Plans and drawings for a project should receive focus only after the specifications have been thoroughly examined and understood. The contractor will then have a better idea of what to look for on the drawings. Most state DOT plan sets also include estimates of quantities, which are necessary to perform a quantity takeoff. We will discuss quantity takeoffs later in this module. Number 2. Perform a pre-bid site visit. This may seem obvious, but this step is often overlooked by contractors who are either inexperienced or overly confident that they know the details of a particular project. Visiting the proposed job site is critical to a successful estimate, as it may bring to light concerns that are not readily apparent in the contract documents. The following is a list of some of the items that contractors should check for when making a pre-bid site visit. Actual travel distance from the office shop to the job site, and will per diem or lodging need to be provided to on-site workers? Is there adequate access to the job site, or will an access road need to be developed? From a visual inspection, what are the soil conditions? To what extent are the clearing and grubbing requirements? Is the site mostly grass, weeds, or are there a considerable number of trees? What is the average diameter of the trees? Are there nearby sources of water and power? Are telephone lines available? What about cell service and internet? Are there nearby wetlands, streams, lakes that need to be protected? How far is the job site to an adequate waste disposal area? If additional labor will need to be hired, is there an adequate supply of labor in the area? Is equipment rental available? And how near is it? How far will contractors and suppliers need to transport materials? Are there nearby sources of concrete and lumber? What security measures will be needed for the site? And will you need traffic control and/or flagmen? Number 3. Attend the pre-bid meeting if one is offered. Pre-bid meetings are gatherings scheduled after an invitation for bid or request for proposal is advertised. They are called pre-bid meetings because they are pertinent to procurement of goods, non-consultant services, and works. When they are scheduled for consulting services, they are called pre-proposal meetings. These meetings, also called conferences, are scheduled during the preparation of the solicitation documents, which are the invitations to bid or requests for proposals. On those, the date, time, and venue are mentioned so that all prospective bidders and consultants can become aware of them. The objective of pre-bid meetings is to explain the details of the solicitation documents to interested bidders. Prospective bidders are permitted to request clarifications on the invitation for bids or request for proposals by a stipulated date, and the pre-bid meeting is held within that period. Perhaps most importantly, the pre-bid meeting is where you'll meet the decision makers for the project and have an opportunity to sell yourself. Number 4. Develop a bidding strategy. There are 2 ways to look at bidding and bidding strategy. The short view, or the get the contract first and worry about the details later, is for the inexperienced bidders. Of course, some details are unforeseen and must rely on decisions made in the field, but this should be the exception and not the rule. An experienced, successful bidder will use the long-run strategy by incorporating planning into the details of the bid. Number 5. Solicit a prime contractor. You'll want to solicit a prime contractor unless you're bidding as a prime, in which case you'll need to solicit vendor and subcontractor pricing. Number 6. Notify your bonding agency. Unlike prime contracts, bonds typically are not required for subcontracts by law and public works. Instead, each general contractor decides whether to require their subcontractors to bond. The general rule of thumb is a subcontract exceeding $100,000 can require a bond. However, a general contractor can make this threshold smaller or larger, depending on the scope of the subcontractor's work and the type of the project. Chances are subcontractors doing more than $100,000 on public works will eventually encounter a bond requirement. On a side note, bonds protect the interests and investments of the consumer, while general liability insurance protects you, the insured, from the financial effects of lawsuits. The primary difference between liability insurance and bonds is which party gets financially restored. Number 7. Estimate the general conditions. General conditions refer to items and costs that are directly related to the completion of the project, but that are not considered part of the completion of specific work tasks. General conditions pertain to on-site costs and should not be confused with general business overhead costs. General conditions are often referred to as job site overhead. There are many possibilities for items that may be included in general conditions for a project. It is a clever idea for a company to compile a list of possible general conditions which can be pulled from and added to with each new job. All contractors differ in what items they term as general conditions. Here is a partial list of items that may be considered general conditions for a highway project. Surveying, temporary construction offices, temporary restrooms, storage structures, on-site telephones, utility bills, security fences, lighting personnel, signage, safety measures such as first aid equipment and fire equipment, fuel, maintenance that's not accounted for under general equipment estimations, cleanup, superintendent or other supervisory personnel, dust control, noise control, and transportation about the site. General conditions can be tricky to estimate. General conditions are usually included in the bid documents, but are not intended to provide a complete list. This total cost is reflected in the bid, either in the form of a line item for general conditions or as a markup for the total contract. Lack of attention to general conditions will reduce or possibly eliminate your profit when you must comply with them contractually. Number 8. Perform a quantity takeoff from the plan set. The quantity takeoff, or quantity survey as it's sometimes called, provides the backbone for the detailed construction estimate. The quantity takeoff is where estimators determine the total number of individual work items to be completed, total number of construction materials needed, and so forth. Examples of items that might be determined in a quantity takeoff might include cubic yards of concrete needed to construct a certain box culvert, linear feet of Type 2 right-of-way fence to be installed, square footage of erosion control blankets, tons of number 4 epoxy-coated rebar. For a given project, there are hundreds of items that are quantified in the quantity takeoff. When performing an estimate, quantity takeoffs usually take more time than any other task that the estimate involves. Luckily for highway contractors, most DOTs go to great lengths to produce various tables that contain estimates of construction quantities, which they place in the plan set. Most of these estimates of quantities come from the plan and profile sheets in the construction drawings. A note of caution though, when performing a quantity takeoff, do not merely reference the estimates of quantities. A careful estimator will also make a detailed reference of the plan drawings and plan notes. There are a couple reasons for this. The estimator must consider the likely sequence of operations in order to anticipate all the cost elements. Plan drawings and plan notes may contain items that are not contained in the estimates of quantities, and the drawings and notes may also display special construction conditions not found in the estimate of quantities. You cannot tell the construction conditions by merely looking at the estimate of quantities. The quantities are not guaranteed accurate. They are almost always accurate, but there can be exceptions. And as a contractor, you will notice cost elements that designers might not notice. The quantities listed on quantity takeoffs can be thought of as real materials such as concrete, base course, or fencing, or aspects that require work, such as finishing concrete or grading. Obviously, not all quantities can be found on a plan set. Finishing concrete, for instance, is a quantifiable element that's not necessarily drawn on a plan set, but that you know needs to be done when you see an exposed slab of concrete. Elements cannot be quantified without first considering how the construction work is likely to proceed. The goal of the quantity survey is to name and separate the quantities of a project for one purpose: pricing them out. The materials and other cost elements must be separated in a logical format. Where should separation occur? If it's different, keep it separated. Good points of separation are when different measurements are used, such as square foot and square yards, different cost levels occur, different work crews are needed, and different work operations are needed. If the quantities are wrong, the entire estimate will be wrong. Regardless of how accurate the pricing information may be, if it's not multiplied to the correct quantities, the estimate will be inaccurate. It is not easy to backcheck a quantity survey. Often, it is cost prohibitive to do so. Therefore, a quantity survey must be performed carefully and systematically the first time it is performed. Don't be afraid to mark up a plan set. It's not a museum piece, and if your firm is serious about performing the work, you will need multiple copies anyway. Use colored pencils to help you divide up the elements on the drawings. Follow a logical order. Complete big picture items first. Estimate each drawing in a consistent fashion. For instance, let's say you are estimating fencing. Your method may be to start in the upper left-hand corner and go clockwise direction, checking all the elements that involve fencing. Do this the same method for each drawing. Use decimal equivalents to make your math easier. Instead of using 2 feet 3 inches, use 2.25 feet. Do not use scratch pads. You need to be able to review your work, and you should be performing your work in sufficient detail that a scratch pad shouldn't be needed for calculation purposes. Try to visualize the method in which the construction work will progress. This will help you discover items that may not be included on the plan set, such as finishing concrete, and will help you determine other cost control elements. Performing a quantity takeoff is done in conjunction with step number 9, determine the units of measure. Units of measure are usually located on the estimated quantity sheet in the plan set, or can be determined by examining drawings and/or the project manual. Here we have a typical estimated quantity sheet for a North Dakota DOT highway project. From this example, we can see that this project will require approximately 526 million gallons of water to complete. Number 10. Determine prices for each element. The contractor is almost always required to provide the materials for a construction project. Material pricing is usually fairly consistent. However, unit prices should be checked against the current prices of vendors that will be used. Sources of material cost information include company records, local vendors, and cost publications such as RS Means, B&I Building News, Suites, and Walkers. Other factors that the estimator should consider when determining material costs include regional differences in availability. There are regional differences in prices for many construction materials because certain materials are more readily available in some areas than others. Southern pine lumber does not cost the same amount in South Dakota as it does in Georgia. With that in mind, it is a good idea to check your local vendors or company historical data for major purchases when performing your estimate. Transportation costs, another consideration, especially for rural highway projects, is the cost to transport construction materials. For instance, if the project is a small stretch of highway 40 miles from a decent-sized city, there probably aren't any concrete batch plants within the vicinity, and unit prices for ready-mix concrete will be increased. Storage. An often overlooked element of material cost is the cost incurred by contractors to store the materials. The materials will be shipped from the vendor to your site, but then what? You will need to store those materials until you actually use them. Is there room at the job site to store materials? Usually on rural projects there's ample space, but what if the project involves a highway through a downtown area? Do you need a staging area, or are you going to have to time the arrival of your materials with the placement of the materials? Do you need facilities such as sheds or work boxes to store those materials? These are all factors that need to be considered. As far as how to actually consider the factors, you need to be aware of the site conditions, another important reason for the site visit. You need to contract your suppliers, and your company needs to have some experience performing that type of work. Quantity discounts. Many vendors will provide discounts for large orders, thus enabling you to lower your estimate. However, you must obtain this information directly from the supplier, not from cost books. Sales tax. As consumers, we are all familiar with sales tax. Be sure to take possible sales tax into account for construction purposes as well. Number 11. Estimate labor. There are three main components of estimating labor: determining labor productivity, labor rates, and then using those results to determine labor costs. Labor productivity is the rate at which crews can produce work. Labor productivity can be estimated by taking the number of workers in a crew and multiplying by the number of hours in a workday, then dividing by the number of units the crew can install in a workday. Let's look at a couple examples of determining a productivity rate. Example 1. A fencing contractor has a crew of 3 workers. They will work an 8-hour day and can install 200 linear feet of permanent fencing per day. Workers get paid on a per-hour basis. Therefore, labor productivity must be known on a per-hour basis. So the contractor must know how many linear feet of fence the crew can install per hour. 3 workers times 8 hours a day divided by 200 feet of fencing per day. This says it takes 0.12 hours per foot. Multiply that 0.12 hours by 60 minutes per hour and you will get 7.2 minutes to install 1 linear foot of permanent fence. This is an average time and there will be some variance. This productivity rate considers paid breaks, walking to the truck to get supplies, water breaks, midday chatter, and other variances because it was computed using the average number of feet installed per day. Second example. A mason crew is comprised of 4 masons and 3 laborers. They work an 8-hour day. They can install 580 bricks per mason. Like the previous example, workers get paid on a per hour basis, and therefore labor productivity must be known on a per hour basis. How many bricks per hour can the crew install? A key point to this example is realizing that each mason can install 580 bricks per day, not each worker on the crew. 7 workers times 8 hours per day divided by 580 bricks times 4 masons equals 0.024 hours per brick. The formula to compute labor productivity is relatively simple. The question becomes, where did you get the data? Unless you have been a fencing contractor for many, many years, how do you know that a crew of 3 can install 200 feet of fencing per day? The single best source for this kind of information is your own company records. Company records show exactly what your company has been capable of in the past. For each job that your company does, data on such items such as total production, time for completion, and crew size should be recorded. If you do not have adequate company records, or you wish to cross-check or double-check your company records, there are other sources of information for labor productivity rates. Publications such as RS Means estimating books and estimating software provide nationwide data on a variety of construction estimating topics, including labor productivity. Trade unions, and sometimes trade organizations, can provide labor productivity rates. We have studied how to estimate the productivity rates, which is to say we've studied how many units workers can install per time. Next, we will take a look at establishing labor rates. Labor rates are a combination of payroll and fringe benefits. Payroll refers to the before-tax amount of paychecks. Fringe benefits include retirement, paid leave, Social Security, insurance, and other items. Government jobs, including work contracted by the South Dakota Department of Transportation, require that hourly pay of specified trades meet or exceed Davis-Bacon wage rates. These wage rates are predetermined by the government, are specific to each locale, and reflect the prevailing union wages of the area. This system ensures that all bidders are placed on an even playing field as far as labor rates are concerned. Davis-Bacon wage rates are public knowledge and can be obtained from the contracting agency or contacts given by the contracting agency. To estimate the cost of labor for a construction project, the estimator must calculate the labor productivity rate to determine the number of hours that particular trades will work, and then multiply that number of hours by the labor rates. Since labor rates are a combination of payroll and fringe benefits, estimating labor rates should come from internal company records and company planning to ensure accuracy. We know the hours per unit. We know from our quantity takeoff the number of units that must be installed. And finally, we know how much we are going to pay the workers per hour. We can now calculate the labor costs. There are many mathematical ways of doing this. One such method is as follows. Labor cost equals number of hours to install 1 unit, which we now recognize as the productivity rate, times number of units that must be installed, times hourly pay rate for the entire crew. Example 1. From our previous fencing example, let's say that we must install a total of 9,000 linear feet of permanent fence, and that each crew member makes $14 per hour. Labor cost equals 0.12 hours per foot times 9,000 linear feet of fence to be installed times 3 workers times $14 per hour equals 45,360. Labor cost for the masonry example is similarly calculated. The difference here is that there are two different rates of pay that must be accounted for. One for the masons and one for the laborers. Also keep in mind that we were given the number of bricks that each mason installs per day. 4 masons, 7 total workers. Labor cost equals 0.024 hours per brick times 7,500 bricks times 4 times $14 per hour, 3 times $10 an hour equals 16,200. Number 12, estimate the equipment. In construction estimating terms, equipment refers to mechanically operated machinery that is depreciating. These items include trenchers, scrapers, dozers, lifts, pickup trucks, and more. Equipment also refers to construction-related devices that are not necessarily mechanically operated, but are more similar to the equipment category than to labor or materials, such as scaffolding. There are 4 primary considerations when estimating equipment for a construction project. Choosing the type of equipment. The work task suggests the type of equipment that will be needed. Site excavation suggests scrapers, dozers. Trenching suggests chain trenchers or backhoes. Determine the production rate of the equipment. The best way for individual contractors to estimate equipment production rates is to refer to the company records and to draw on experience. It is good practice for a contractor to record production capacities as it performs each job. This provides a quick, accurate way to assist in future estimates. If adequate company records are not available, or if there is a desire to verify company records for application to a certain job, there are other sources of information available. Equipment manufacturers and vendors can provide capacities, operating speeds, and other things. Industry publications, such as RS Means, can provide unit costs as well. Cost of operating the equipment on the job site. How much does it cost to run each piece of equipment for each hour? Consideration includes, if you own the equipment, determining the hourly rate of return. If you are renting the equipment, determine the rental rate. Fuel costs and maintenance costs. Obtaining a value for rental rates is as simple as obtaining a quote from a vendor. If a piece of equipment is owned, then determining a rate of return is a bit trickier. This is mainly a matter of personal preference on what the owner determines is a fair and reasonable rate of return. A few considerations might be rental rates for similar pieces of equipment, cost of the purchase, insurance, and lifespan of the equipment. Determining the cost of moving the equipment to and from the job site. Mobilization to and from the job site can be expensive, especially for large pieces of equipment and for transport over large distances. Company records and quotes from transport firms will aid in this estimation. These costs are then spread to the unit cost, hourly or daily, of operating the equipment. Number 13, determine overhead. For the purposes of this training, overhead will refer to home office overhead as opposed to job site overhead. Job site overhead, also called general conditions, are covered in the general conditions section and calculated as a separate component of the estimate. Overhead represents the fixed cost of being in business that cannot be charged to specific projects. These expenses are usually incurred regardless of the amount of work the organization is performing. Overhead expenses might include equipment, salaries and benefits of office personnel, such as office administrators, estimators, or executives, home office purchase costs or lease costs, home office utilities, insurance, advertising, charitable donations, or other miscellaneous expenses. Overhead costs do not appear in estimates. Rather, they are included as part of an overall markup. The markup can occur on a lump sum basis or on an individual cost element, depending on the bid documents issued by the owner. Overhead costs are only roughly computable. As a standard business practice, every contractor should know what their overhead costs are over a period of time. Then, anticipating how much business they will do over that same period of time, a percentage of markup can be applied to each project, such that the summation of all the overhead markups cover their actual overhead costs. This is an example of an overhead analysis form used to calculate a single-tier indirect rate. The applicable FAR, Federal Acquisition Regulation, that addresses overhead costs is Part 31, Contract Cost Principles and Procedures, and particularly relevant is Subpart 31.2, Contracts with Commercial Organizations. Here you can research indirect costs, Subpart 31.203, and allowable costs, Subpart 31.205. This form should include home office overhead costs for the preceding 12 months or most recent accounting period. Number 14. Determine the acceptable level of risk. All construction projects involve some degree of risk, and a good estimate will take that risk into account. Estimating the monetary value for risk is one of the more elusive quantifications that are made on construction estimates. Ultimately, the amount of markup due to risk depends on the amount of risk the management is willing to take. The estimator's goal is therefore to assist management by quantifying the risk involved. When referring to risk in a construction estimate sense, risk involves adding a contingency either to individual construction items or to the sum total, which can cover charges that some likelihood of occurring. The contingency does not include changes in scope, force majeure, an act of God, or other items, because these costs are recovered in change orders and other contractual agreements. The main sources of risk for construction projects may be summarized as follows: site conditions, location, working relationships such as reputation of the owner, prime contractor, subcontractors, or designers, market conditions, environmental concerns, public opinion, and construction methods. Quantifying risk usually comes from one of two methods: experience and statistical analysis. Number 15. Determine the markup for profit. Estimating the profit on a job is a strategical decision handed down by company management. The profit is usually estimated as a percentage of the total bid amount. The percentage depends on many factors, such as anticipated competition for the job, company workload at the time of job performance, current marketplace trends, familiarity with the duties to be performed, strategic desire for the company to grow or to downsize, strategic desire for the company to break into a new market. This is an incomplete, non-comprehensive list intended to give you an idea of the concepts that shape the amount of profit that is figured into the bid amount. For the estimator, it is good to know that the profit markup is handed down from company management as a result of strategic thinking. Number 16. Calculate the markup for bond. With most projects, the burden of bonding is carried by the prime contractor. Therefore, as subcontracting DBEs, markup for bond is not typically an issue that will need to be addressed. When it is necessary to calculate bonding for markup, the cost is computed as a percentage of the total bid amount, typically between 0.4 and 0.8%. The exact percent is determined through agreements with your bonding agency. Number 17. Finalize your estimate. To finalize your estimate, you'll simply add all the separate costs that you've calculated, such as materials, labor, equipment, and other items, and multiply the sum by the markup, which is the cumulative sum of the overhead, risk, and profit markup percentages. And don't forget that you'll have to pay Uncle Sam. Be sure to add tax when applicable. Here are some other estimating tips that will be helpful as you estimate jobs. The number one goal when performing an estimate is precision. The estimate should not reflect the cost for the typical firm to complete the work, but should rather reflect the cost for your firm to complete the work. To this end, the estimator should tailor the costs obtained from the cost information sources to their particular firm as they see fit. The most accurate way to estimate jobs for your company is to reference past projects. Record the following for each project to use as a basis for determining future estimates. Actual man-hours spent on each task, labor rates, actual unit costs of materials and transport, materials purchased versus materials used, equipment production, rental, and operational rates, equipment maintenance costs and schedules, actual downtime for different types of equipment, and profit or loss resulting from project. The internet can be a great place to begin your research. You may also find it helpful to talk to other contractors and see what they use. Most major estimating software offer free demonstration programs that you can sample to see if you like the software enough to purchase it. Estimating software can make estimates more quick and efficient to produce and update, but there are a few considerations that the small contractor needs to be aware of. Estimating software can often cost over $3,000. It will require a considerable time investment to learn how to use it to its potential, and it may be necessary to go to formal trainings to learn how to use it. Do you need estimating software to be competitive in today's world? The answer is, it depends. If you are a large contractor, not only is it highly advisable, but you probably already have estimating software in place. If you are a small contractor, it may not be in your benefit to use estimating software. If you know your business well, if you are comfortable doing arithmetic, and if you are comfortable with basic computer applications such as spreadsheets, then you probably do not need to use estimating software. For estimating or other business development assistance, please contact Project Solutions, Inc. We can help with things like business plan development, record keeping, tax issues, employment issues, insurance and bonding, loan applications, computer solutions, bid preparation, estimating, scheduling, and business reviews. For more information regarding the estimating or bidding process, please contact myself, Danae Johnson, at Project Solutions, Inc. at the phone number or email shown on the slide. I look forward to working with you. And thank you from Project Solutions for taking the time to watch this training module and to invest in the future of your business.